This is the sixth episode of our Chinmaya Algebra series. For this question, we are given a system of equations involving x, y, a, and b as shown. Now the question is to find the value of the product of x squared plus y squared and a squared plus b squared. I have tried some methods for this one, but nothing seemed to be more efficient than just solving for x and y. So for this video, I'll put in a solution that involves solving for x and y. If you figure out another solution without directly solving for x and y, then let me know in the comment section. So we can solve for x and y here by using the method of elimination. We can multiply the first equation by a and the second equation by b, so that the first one becomes a squared x plus aby is equal to 1. The second equation becomes b squared x plus aby is equal to 2ab squared over a squared plus b squared. If we subtract these equations, we get a squared minus b squared times x. The y cancels out. So we have the right side as 1 minus 2ab. Sorry, this one should be a. We have a minus 2ab over a squared plus b squared. If we factor out the a here, we get a times 1 minus 2b squared over a squared plus b squared. And then simplifying it further by using the greatest common denominator, the least common denominator, we get a squared plus b squared minus 2b squared over a squared plus b squared. And then simplifying it further, we get a squared minus b squared over a squared plus b squared. Now the left side here is a squared minus b squared times x, which comes from this part. To solve for x, we just divide both sides by a squared minus b squared, assuming that a is not equal to b. Well, assuming that a squared is not equal to b squared. So this one cancels out. So we are left with x is equal to a over a squared plus b squared. So that's one variable down. We put it here. And then the next step would be to solve for the variable y. We can use the same method, but instead of multiplying by a and b, we can multiply by b and a to get the same results. Or we can just make use of the first equation and the value of x. So if we substitute the value of x in the first equation, we get a times a over a squared plus b squared plus by is equal to 1. This becomes a squared over a squared plus b squared plus by equals 1. So by is equal to 1 minus a squared over a squared plus b squared. Using the same method earlier, we get b squared over a squared plus b squared. And then if we divide both sides by b, this would cancel out, leaving us with b. Therefore, y is equal to b over b over a squared plus b squared. Almost analogous as a. Actually, without solving for this one, we could argue using symmetry that the result for y should be something related to x, but instead of the numerator being a, it would be b. By using the symmetry of the equation with respect to x and y. Then finally, we will be solving for the required expression, that is x squared plus y squared times a squared plus b squared. We have x equal to a squared plus b squared. So the square of that would be this. Similarly for y, we get this. Let's just put this a little lower. Okay. And then we multiply this product by a squared plus b squared. The first term has a common denominator of a squared plus b squared squared, and then the numerator would be a squared plus b squared. Multiply that with a squared plus b squared, and we get 1. Therefore, the answer to this problem is 1. And that's our final answer. Again, if you figure out some alternative solution without solving for x and y, then please let me know in the comment section. Hope you learned something today. Thank you for watching, and please subscribe for more content.